Well, hello again, ladies and gentlemen. Welcome to VK2 ERG's station and workshop. Today's topic is actually gear cutting. So we start off with showing you the setup on the vertical mill. So the mill used here is a X3 that I acquired from here in Forbes. So what you see here, we probably are about a dozen steps ahead now, because one of the first things you need to do is prepare the gear blanks. So mounted here at the moment is actually a brass gear blank. But anyway, we started off from a big chunk of 76mm solid brass rod. So all that's left of that 100mm is just what I have over here today. So this is it. So that's the original finish, and what I had to do is turn it down like this to make the get rid of the finish as it comes out of head-cone steel, and then had to bore that to exactly 16mm. That's the arbor size of what's mounted in my lathe. So the gears I'm making today are meant for the change gears of the lathe. So that's been faced, that's been turned, that's been chamfered over there. So that's what the gear blank looks like when it's not parted off from the main piece of material. So other bits of preparation, of course. Aside from that, had to make a mandrel over here, so that mandrel holds the gear blank in place, and I made that one to be small enough so that it fits into this chuck over here. And then I had to make an arbor to hold the gear cutter. So that gear cutter there was the one I got from CTC Tools in Hong Kong, and that's part of the mandrel being shown over here. So the shaft itself is held by this collet, and there's the bottom there. So it's just being held by M8 high tensile screw. And of course, this is an earlier acquisition. This is the rotary table mounted vertically now. An accessory of that one is the dividing plate. So depending on the number of teeth that you'd like to cut, use the proper or the appropriate dividing plate, and you have the exact number of holes over here. So in this case, this particular thing that I'm going to show over here is actually a 70 tooth gear for the lathe. Now that's just showing you the chart on the lathe. That's where the 70 gear will be used to be able to cut those threads from 0.7mm all the way to 1.25 millimeters per turn, or that's the pitch in metric. The other gear that I made yesterday was a 72 tooth one, and I'll be making the others for the other threads that I need to make in the imperial thread. So as you see, I don't have a 65 gear over here to make 26. That falls right in between that, between the 24 and the 28. So I'll have to make a 65 gear as well. Alright, looking closely over here, you'd see that I've already cut a number of teeth, and the depth has already been set with the cutter cutting into the brass. So what we need to do next is actually position the head over here to cut the next tooth. If I bring you all the way here, you'll see that dividing plate is positioned at a certain hole. Now for a 70 tooth gear, there's a number of turns that you have to make on the crank handle, and the number of holes that you need to increment it by to get the exact number of degrees. So this one here is the sector, so that's what I'll do next. I'll just put it there. I'll have to let go of the camera for a little bit here so I can do the crank. So what I've done is actually moved that sector arm over there, made one whole revolution all around, and then landed at the 6th hole over there, which is marked by this sector arm. So the sector arm is actually just a way of marking which hole you need to land into after you make your turn. So that would have moved it by about 5.14 degrees. We really don't, that's not gonna be really much help, but that number of holes that I had to move came from a table which comes with the dividing plate. So going back here, the cutter is now in position and ready to take the next cut. So I'll just mount the camera on a tripod and we'll go ahead and proceed with the cut. Okay, we're all set to go. So you can see that the cutter is now poised to cut the next tooth, and I'm just about to start the mill motor, and you may not hear me talking over that. So what we'll do is we'll just focus on this particular scene over here. I'll turn on the motor, do the cut, and then we'll get back to you. So we'll leave you there. So that completes the cut. So the speed of the mill will be about 400 RPM, and the depth of the cut is 2.16 millimeters as specified for this particular pitch. This is module 1 pitch on the gear, and that was it. So the easiest part really of cutting the gear is actually just doing the cut. It's all the preparation and all the setup that requires a lot of work and patience. So just setting up the equipment to work the way it should be, setting up the rotary table, setting up the dividing plate as you saw, and then doing the other measurements as we go along. So that's it for this particular scene. Hope you enjoyed this segment on gear cutting. Of course, nothing at all to do with amateur radio at the moment because this goes on the lathe, but there will be other projects that will involve gears, especially when we make our own rotator for aerials. Probably not something as big as this one, but it will probably be a small VHF aerial that needs rotating. So there you go. Cheers for now from BigC to ERG.
Magkano po? Mga 70, almost 70.